Hello, everyone. Welcome. We're glad to have you here with us at our 2019 Arizona Authors Series. This is part of our State of Arizona Research Libraries programming, and we are very pleased today to have our special guest be Dr. Ray Grant. We've invited him to share his extensive knowledge and his enthusiasm for minerals and gems of Arizona. So I'm going to tell you a little bit about Dr. Grant, and then I'll turn the time over to him. Dr. Grant is a retired professor of geology, founder and curator of the Pinal Geology and Mineral Museum, founder and president of the Pinal Gem and Mineral Society of Arizona, past chairman of the Flag Mineral Foundation, mineralogist, author of the Checklist of Arizona Minerals, first and second edition, co-author with multiple people of Mineralogy of Arizona, third edition, and the Mineral Collector, Florence, Arizona. He has had a mineral species, Ray Grant, named in his honor, and is featured in mineral collections in Arizona, the May-June 2013 supplement. He received his PhD in geology from Harvard University, and he was professor of geology at Mesa Community College for over 25 years, and part-time for another 5 years. He obviously brings a wealth of knowledge to us today, and we're very glad to have him. And without further ado, I will turn him over to him. Please help me welcome him.
Holler up. I've got this mic up because I've stopped teaching, so I've lost my teacher's voice that I can boom out at those kids. It's gone, so you'll have to put up with my retired voice. So anyway, talking about the Mineralogy of Arizona. So the reason I'm here is because of the third edition of the Mineralogy of Arizona, which I was co-author on. There's 3 editions. The first edition is actually over there on the table. It doesn't have this writing on it. I'm not allowed to touch that. A little bit of rain. Maybe we should just turn that down a little bit. So there were 577 minerals in the one that's over there on the table. And then the second edition, which they didn't call it a second edition, they called it a revised reprinting. And all they did was stick the extra pages in the back. They didn't change the text at all. But then in the third edition, we rewrote the whole thing at 809 minerals on it. So these are the co-authors that were on the third edition, John Anthony, Sid Williams, and Richard Peridot. Fantastic people, just contributed an unbelievable amount to the Mineralogy of Arizona. Unfortunately, they've all passed away, and I'm sort of left over. But we're almost done. We have a 4th edition. I've gotten a lot of people to help me. It turned out to be a really big job. We have over 950 minerals. We're going back to the University of Arizona Press, who did the last 3 editions. And 2020, maybe. I'm not sure. I'm not as optimistic as others, but we're almost there anyway. So within the next year or 2, you should see another edition. You can still buy this. It's still in print. The University of Arizona has it. I think they have a couple dozen copies left. $39.95. You can go on Amazon and get it for $10. They have the hardcover edition over there, and I see those for up to 100 or 200 even for some reason. I'm not sure why. But anyway, that's the whole reason that I've been invited to come over here. So I'm going to look at the mineralogy. There's thousands of publications about Arizona minerals, but these are the ones that have lists where they've actually tried to list how many minerals have been found in the state. So the earliest one, 1866, and the last one was one of the checklists that I did. And then, of course, we'll have the new edition hopefully soon. So William Blake started out, and in 1866, he actually just had a list of California minerals, and he had 14 minerals that were found in Arizona that he listed at the end of his California thing. So that was the beginning. He did come to Arizona then, and he was a professor of mining and geology at the University of Arizona, and he became territorial geologist. So he published the first real list of minerals from Arizona as a report to the governor in 1909, and they probably have it hidden here in the archives somewhere if you were curious. So this is what it looks like, Minerals of Arizona, a report to the governor, and William Blake, territorial geologist. He had 102 minerals. What's really interesting, at exactly the same time, Frank Till was a professor of chemistry and mineralogy at the university. And remember, that Blake is a professor there too. And I have a feeling there's a little competition there. Because a year later, Gill published this book, Mineralogy of Arizona, and he had 130 minerals from Arizona in his book a year later. So I think it would have been interesting. I try to imagine these two guys, professors at the university, I got more minerals than you got, this kind of thing. Then the next couple come from the university too. 1941, Gil Brandt, 267 minerals. He had a revised edition in 47, 284 minerals. He had a third edition in 53, 377 minerals for the state. They reprinted it, but they didn't change anything, so this is exactly the same as the 53 version. And these are all online now. The Arizona Geological Survey has all the publications online, so you can go and find these things if you need to find them. So that was pretty much in Tucson, with all the Tucson. In Phoenix, we had Arthur Flagg at the Mineral Museum over at the fairgrounds, and he put out a book in 1958. He actually has lists in his book about mineralogical journeys, and his list had about 400 minerals in it for the state of Arizona. And then I did these two checklists. The Mineralogical Society of Arizona published the first one, 605, and then the State Department of Mines published the second one. We had 869 minerals. And I think we're up to 954 now for our new edition. So the question I have is, why do we have so many different minerals? And 950 minerals, Arizona probably has as many minerals. I'm not sure we have the state in the United States that has the most minerals, but we're very close to the top if we aren't the winner in that. Mines and prospects, the Department of Mines has files in like 10,000 different holes and mines scattered around the state. And we have the gemstones I'll talk about a little bit, just millions of dollars worth that have been mined here. So it's extremely rich. So I'm going to go over these three different times, just briefly, to give you a little background information. In the Precambrian, 1.8, 1.7 billion years, these are the three times when most of the big ore deposits were made or deposited in Arizona. What geologists have given the name Laramine, 70 to 50 million, and the Tertiary, 30 to 15. And so my premise is Arizona was in the right place at the right time. It was at the place where these minerals were going to be deposited. And so we have all these different minerals. And it's all related to plate tectonics, and we could do a whole series of geology lectures just about plate tectonics. But just real quick, we have the spreading zones in the ocean. I can't touch that. Like the mid-ocean ridge in the Atlantic or the East Pacific rise, so new ocean crust is forming, and we have the subduction zones where they go down. So, we have the divergent and convergent plate boundaries, and we'll see that the mineral deposits are related to all these different things, these different plate boundaries. So, if we go out in the ocean and we have hot magma that comes up, it forms the mid-ocean ridge, and the ocean spreads apart. The Atlantic Ocean is getting bigger, an inch or so a year as it spreads apart. But it turns out that seawater is able to, as these rocks cool and move away, they crack up. And seawater permeates down through and it gets hot. It turns out that hot seawater is a really good solvent for these metals. So there's a tiny bit of copper, a tiny bit less even molybdenum, lead, silver, gold, whatever, sulfur in this rock, in the seafloor rock. And the seawater dissolves all of these preferentially to the other elements. And so we'll see that that's the beginning right there in the ocean floor of these mineral deposits in the state of Arizona. So what happens after it reaches the metal, and of course, this is deep ocean stuff and the black smokers. I mean, that's all stuff that people have learned about long since I had elementary geology, way back years ago. And when that hot water comes up with all the metals dissolved in it, it's really hot, 350 of when it hits the cold seawater, all those metals precipitate out. So the black smoke is actually pyrite and chalcopyrite. It's actually metal sulfides that black smoke is settling on the ocean floor. So we have these areas of deposition. We call them black smokers, and there's lots of pictures of them available nowadays. People have gone there and collected samples. Another picture. So this is just chalcopyrite that was collected off the ocean floor. But look at that structure, because I'd like you to think about that in a few minutes. So it turns out that the copper can be up to 10%, so it's like 100,000 times enrichment of copper over what was in the original rock. The seawater dissolves it, comes out of that hot spring, that black smoker, precipitates as chalcopyrite, which, if we could go down there, it's a little bit deep, nobody's mined out there in the ocean floor, but essentially ore deposits are forming there. So now, if there's some way to get those things in the ocean up onto the land, then we could, they're obviously going to be ore deposits. So it turns out that our oldest deposits, the ones that are from the Precambrian, 1,700,000,000 years ago, are ocean floor sulfides that got pushed up and became part of Arizona. There was no Arizona before about 1.8 billion years. This was just ocean. And as the continent kept getting bigger, some of these deposits from the black smokers became part of Arizona. And you can see where they are. They're mostly in Yavapai County, the massive sulfide deposits, a few scattered other places, but that's the main point of where they are. So the biggest one, the richest one, is Jerome, United Verde Mine. So it was $1 billion copper camp. Population 15,000, 10, 5, 1, Ghost City. This is a picture I took in about 1975 when I went to Jerome. Not a ghost city anymore. The United Verde Mine is the main surface working that you can see there. And these kinds of structures were found in the mine. And so just in the last 10 years or so, geologists have decided that these are really remnants of black smokers that got pushed up. Those sulfides in the ocean floor got pushed up and became part of Arizona. And if you'd like to see them, go to the Jerome State Historical Park. It's very nice. It's in Jerome. It's the old Douglas house or whoever's house. They have a nice model of the mine. I mean, there's literally hundreds of miles of tunnel underneath Jerome, all the besides the pin on the top. And this is a sample that they have there in the museum. It's a black smoker sulfide column, virtually identical to modern counterparts observed in the ocean floor today. So they actually found these black smokers in the mine. They look exactly like black smokers. So we start out with this tiny bit of copper in the ocean floor. The seawater dissolves it, deposits it on the ocean floor, gets pushed up into Arizona, and we have $1 billion worth of copper in Jerome. The other thing that happens then, of course, is if we keep making new ocean, we have to get rid of it somewhere, or the world will get bigger, and we get rid of it by subducting it. So any of these black smoker deposits that are present if they don't get pushed up on the continent, like they did in Jerome, they get pushed down. Well, what happens when they go down? Well, then there's a whole lot that gets hotter and hotter, and you got hot water, and it redissolves them all again. So all those metals are dissolving for the second time, and they will then start moving up, you know, into the crust, into the surface of the earth. And depending on the temperature, this isn't critical, but you get different elements dissolving at different depths, because the deeper you go, the hotter it gets. And so exactly what you're going to get in Phoenix, or what you're going to get, you know, at Superior or you know, Morenci, would depend on how deep the subduction is. And the subduction zone can change angle. And so as it would change angle, get shallower or deeper, you would get different metals deposited. So this time period when we have the major subduction here, what the geologists call the Laramide, is 70 to 50 million years ago. And they made up a name because it covers more than one, it's part of the Mesozoic and part of the Cenozoic. So they just made up a name for it, Laramide, because that's when all the big current copper deposits were formed in Arizona. So Baghdad, Christmas, Inspiration, Morenci, Ajo, Ray, this is Morenci, they all formed at that time. They're large, millions of tons of low-grade ore, copper content in a lot of them, but their mining was just 0.5%. And you can see where they are. They have a list here of 37 of them, a few in New Mexico, a few in Mexico, but most of them are in the southeastern part of Arizona, but we have the ones Baghdad and Mineral Park up north of Kingman. And most of you know about Ray and Morenci and Inspiration and, you know, these different mines. So that's the time period when those mines were formed. Then the final period of activity, we call it the mid-tertiary. If you were here at the right day, 30 to 15 million years ago, and you went outside, this is what it would look like right here in Phoenix, downtown Phoenix. Well, 30 million years ago, that would have been there. Well, why? Because that's when the Superstition Mountains formed. And the Superstition Mountains were a violent, volcanic, explosive range of mountains. And the ash would have been everywhere. The ash would have covered, you know, hundreds and hundreds of square miles. Most of it, of course, washed away and it's gone. This is where you can find it today. You know, wherever the black is where the Superstition volcanic rocks are right now, today, that you can see. So they formed in that time period. Okay. And the Apache Tears at Superior formed then, part of that volcanic sequence. And the deposits, you can see pretty well across all of southern Arizona, a lot of them in La Paz County, in that part, up in the western part of the state. But quite a few large ones here, Mammoth St. Anthony Mine and things like that. So those are the three time periods that we have for, you know, the ore deposits, and a few minor things in between, but those three times, you know, are the times that we were at the right place at the right time for the ores to be deposited. So just sort of a summary, hot seawater dissolves the metals and it dissolves the sulfur. So they're deposited wherever that hot water gets off as sulfides. Pyrites, iron sulfide, chalcopyrites, copper, iron sulfide, etc. This chalcopyrite is copper, iron sulfide, about 35%. It has been in the past the most common of all the copper ores, or the mineral that most of the copper in Arizona was mined from, at least as long as they were smelting it using the sulfides. And this is what it would look like. There'd just be narrow little veins, and it might be 0.5% copper, 1%, you know, because they open pit mine, they take everything and try to separate out, you know, whatever the copper is. Galena is lead sulfide, so there's a vein of galena, such a red cod mine down a little bit. There's a couple of galena crystals, just a picture of them. So now we have the basic thing. We have these primary sulfides that are deposited here. But I've only talked about 4 or 5 minerals so far, pyrite, copper, pyrite, blue sky. Well, it turns out when you take these sulfide minerals and you rain on them and you have air, oxygen, they react and they form sulfuric acid. And probably you've heard of acid mine water. It's sulfides reacting with oxygen in water, forming sulfuric acid. So the minerals are dissolving, and they're going to move down until some reason they either precipitate out, the acid gets neutralized, or they get to the water table, and below the water table, the pore space is all filled with water, so there's no oxygen, so you lose the oxygen part, so we don't get the oxidation. And I think part of the thing about why we have so many minerals in Arizona is because generally the water table is relatively deep. I mean, some places it's near the surface, but if the water table was near the surface, then I'd have to compress this whole thing down to a really narrow, tiny bands, because the last bit of reaction is just below the water table. So the copper, the lead, the zinc, all these things are dissolving. The only thing that doesn't dissolve generally is the gold. It's still left there on the top if you want to go look for gold. I just like to show the Sacaton line because it shows it pretty well. South of Casa Grande, they just put this pit in, they took what they thought was good, and that was it. So, started, took out the richer store and left. And it looks like this. So here's the oxide and the iron oxide. Everything's leached out. It starts to reprecipitate if it's neutralized, and we'll look at that in more detail. Below the water table, which is obviously lower now, would be the enriched zone. And then this is just the original stuff that was deposited here. So this enriched zone, the copper mineral is now changed over to calcite, and it has 80% copper, so some of these enriched zones are really quite valuable, worth mining, and that's why that Sacaton mine was there, because of the enriched zone. So the top layer, where everything is leached out, the iron oxide zone, iron oxide, it's rust, right? So the old guys would come wandering around Arizona and they look for these rusty hillsides or rusty places because that's where you'd start to dig down, because that would be your iron oxide panel, and the richer ore, of course, would be down underneath. So the early thought sections learned that, and wherever there was a iron oxide and rusty zone, they knew that was a place where they should dig to get to the richer ore. The oxide zone is where stuff starts to reprecipitate. Okay. And it turns out, as far as mineralogists and mineral collectors go, the oxide zone is the thing that most of us care about. There are actually literally hundreds of different minerals that have formed in that zone. And they're quite attractive things, as you'll see. And so those are the minerals we want. I mean, some people might collect chalcopyrite or calcite or these sulfide minerals, but most people really like these things. So things like azurite, copper carbonate, chrysocolla, copper silicate, cuprite, copper oxide. You can see all of these have oxygen in them, so they're in the oxide zone. Cerussite, lead carbonate, hemimorphites and zinc silicate, or calcite, get combinations. So we get all kinds of different, just different kinds of minerals. Smithsonite, zinc carbonate. So this oxide zone is rich and it has this tremendous variety, just all kinds of different minerals. So I just briefly wanted to throw in a little section about type mineral localities. So the first place any geologist, mineralogist finds a mineral is called a type locality. It's called a type mineral. So we have about 81 minerals that were first found in Arizona before they were found anywhere else in the world. Okay. So one of them is Kenoite. This is the only picture I could find on the internet of Padre Keno, somebody's drawing. Well, it turns out John Anthony, who was one of the authors, I shouldn't always tell his story, but his dog was named Keno. And he submitted the mineral, and he said he named it after his dog. Well, they rejected it. They said, you can't. There's an international committee that accepts these names. They said, you can't name a mineral after your dog. So he rewrote it and said, well, no, it was named after Padre Keno, famous Arizona Jesuit, you know. But we all know, I mean, all the mineral people know, it's a copper silicate. So it's one of these secondary minerals. About 50 or so of these minerals are named after people. 20 plus or so named after places, and then just a few other things like chemistry or some other obscure thing that they were named after. Just another example, the Grand Reef Mine over in Grant County, really favorite place for mineral collectors. The main entrance goes in here. The whole mountain is hollowed out, and you can look all the way up there. You can look in there and see all the way down. And this is Laurel Creek or Laurel Canyon. And so the clear crystals are called Grand Reefite, and the white fibrous stuff is called Marlite. So the common thing where they're named after places. And for people that live around here, I put Mineralogy in. It comes from the Moon Anchor Mine, which is out past Tonopah ways, and it's a lead silicate. But all of these, the Kenoite, the Grand Reefite, the Mineralogy, they're all secondary minerals. They're all minerals formed in that weathering process, the leaching and the movement of those solutions. And we have just so many different ones. So we have one named after this county. We have a Pinalite too, since I live in Pinal County. So I think about half a dozen of the counties have minerals named after them. Apache, Hawaii, but they may be named after tribes and not counties. Then I just wanted to show you a few localities that were mined for mineral specimens, okay, where people were just mining for minerals. They were not commercial mines. They had people just mining. So the Blue Ball mine, which is just south of Miami, the big clay outcrop, they just chiseled it with an air chisel because they were just digging in the clay. And they were looking for these nodules of azurite. Some of them had malachite in them. And they were used to make jewelry and things like that. And they worked there for some years. And this is just one time. There were thousands, tens of thousands of those nodules. Well, I mean, I don't know, maybe 100,000. I'm not sure how many. I mean, this was one time. Look at them all, just bucket after bucket. And this is just one of the deliveries. They were all split with a pipe cutter. So you can imagine several people working 8 hours a day, splitting each of these open to see what the mineral looked like. Quite an undertaking. Wulfenite, it happens to now be in 2017, it was declared the state mineral. I just heard we have lemonade now as the state drink. I think that happened this last session of the state legislature. Anyway, Wulfenite, and of course, if you're not a mineral collector, people ask, well, what's Wulfenite? I've never heard of it. Why is that the state mineral? But anyway, it's lead, molybdenum, oxygen. So it's an oxide zone mineral. Looks like that, and it's a state mineral of 2017. And probably the most famous Wulfenite locality in Arizona, the Red Cloud Mine, north of Yuma. There was, when I first came here, again, this is back in the 70s, there were some remnants of the town of Silent was there, but they're pretty much gone now. Because they put a big open pit in. In the early 80s, the price of silver was high, so they reopened the mine for a while and they put in this new structure. Price of silver crashed, the miners left, and I think within days or weeks, one of the mineral collectors came there and wrote Wulfenite is love on the ore chute there. It was on the original Wulfenite club, we think, was on an old wooden shack at the Red Cloud. That was written there probably back in the 60s, and then the shack was burned down. So this is one of the mineral collecting things where the dealers set up just to dig for mineral specimens to sell. So you can see these are just Wulfenites, and if you go to the Tucson show and look at the Wulfenite specimens, you get an idea why it's worthwhile doing that if you start looking at the prices that people are getting for these things. And it is an attractive mineral. There's one. This is one I happened to collect just after the mine closed down and those guys left. It was a good time to get in there. This is another one. This one was collected way back in the 30s. It was used on the stamp and the Bisbee azurite. So 2 minerals from Arizona have been on stamps. Okay, then in the program thing, so I talked a little bit about gemstones. And it's important because it relates to all the things we're talking about. There's no diamonds, no emeralds, no rubies or sapphires that I've seen yet or that we know about or we're reporting from the state. But we have peridot, turquoise, malachite, azurite, petrified wood, amethyst, garnet, opal, lots of other things that have, really been mined in the state. One of the first, Kunz has this book, Gems and Precious Stones in North America, so 1890, so he lists peridot, turquoise, petrified wood, amethyst, agate for the state. I think this is the first publication specifically about Arizona itself, Gems and Precious Stones. Again, this is online. If you go to the Geological survey, all of their publications are online. So this was bullet number 48, it looks like. Okay, and so it lists a bunch of minerals. And lots of mineral collectors. This is a book Martin Koenig wrote about collecting gemstones in Arizona. So we do have an official gemstone, turquoise. So we have an official mineral, Wulfenite. We have an official gemstone, turquoise. Okay, and of course thousands of tons. And turquoise is copper phosphate, so it has oxygen. So it came from that oxidized zone part of the mineral deposits. And most of the turquoise came from the major copper mines, although some of them were mined just for copper. And for some reason, Native Americans were able to collect turquoise and use it. And if you go around to, bunches of the different ruins in the museums, these are things I've taken pictures of in some of the museums, Native American ruins. Just to show you a few, Sleeping Beauty mine near Globe, Kingman, which is Menlo Park, really. Bisbee, they didn't have a lot, but some of the best turquoise in the state came from Bisbee, really good. And some of the other copper minerals we talked about. So, malachite, azurite, chrysocolla, this is a big slab, giant thing in Baghdad. The malachite is green, the azurite is blue, the chrysocolla is turquoise color. So malachite, the only problem with things like malachite and azurite, they're not really very hard. So, they look really good, but you have to be a little careful because they're kind of soft for gemstone. Azurite, this is the specimen that was on that stamp. We had the 2 stamps from Bisbee that was used for the United States 1992 mineral stamp. Chrysocolla. This material is mostly quartz that's colored by chrysocolla, and some people call it gem chrysocolla, some people call it gem silica. And if it's the quartz colored by the chrysocolla, then it's quite hard, much harder than just chrysocolla by itself. And this material has become really quite valuable. If you have good pieces of that, it's become quite a valuable gemstone. Peridot, I think if we didn't have all that turquoise, peridot would have been the state gemstone easily. For years and years, Arizona produced more peridot than almost anywhere else in the world. I know that if you went to Hawaii and you bought something, peridot, it actually came from Arizona, no matter what they told you. There are a few more places now around the world where they're getting it. It comes from the San Carlos Apache Reservation. It's the main place. This is an outcrop. This is several feet high. I mean, there's literally just limitless tons of peridot there, at the San Carlos Apache Reservation. There's a bunch of claims, I think. When I was there, I think they said about 50 or 60 families have the claims. And so each family has the right to dig. And of course, a lot of it's sandy, so they're digging, trying to get the bigger pieces of peridot that are cuttable, that you can tumble or you can facet. And they do get to be pretty nice. This is a specimen from the Smithsonian, 34 carats. So you can see that it's, potentially there has been some really nice peridot at Stanley Butte, or peridot. Beryl, aquamarine, we don't have emerald. Gemstones have their own special name usually, so the mineral is beryl. If it's chrome green colored, it's called emerald. If it's clear blue, it's called aquamarine. If it's yellow, just like we'll see for quartz, we have all these different names. So in the Serena Mountains south of Tucson, I've seen the U of A had a large facet and stuff in there. These are just a couple of specimens. They're not quite gemmy, there's some gemmy stuff. Garnets. The original garnets that were found here way back in the 1800s were called rubies, Arizona rubies. They're not rubies, they're the mineral peridot. They're found on the Navajo Reservation where they weather. The rock is actually kimberlite, which of course a lot of the diamonds in the world come from. But with all the studies and searches and everything they've done here, they think we don't really have or expect to find diamonds here in our kimberlites. This is what they look like. So you can see why they were called rubies. And Kuntz in his 1890 book said they were found on anthills, which is true. That's how all the first people found. The soldiers, people came by, the ants would bring up the gravel, the loose stuff, and people would pick up the ant and pick them up off the anthill. And he also thought that scorpion excavations maybe made them. So I did find this. I think this scorpion really wanted to collect garnets. Okay, so quartz, very common mineral, one of the most common minerals in the Earth's crust. And hundreds of names for all kinds of quartz. Okay? Depending on what it is. Rock crystal, amethyst, citrine, petrified, all the different agates, fire agate, chalcedony, jasper, chert, flint. I mean, those are all quartz. They're all the same thing, SiO2. And they just have different names depending on the texture and depending on the color. And we have, lots of them. So we have an amethyst mine, 4 Peaks, up on that side of the 4 Peaks mountain range. You can go there by helicopter. I think if you look it up now, I think in September they're having trips again. You can pay to go up there by helicopter. $500?
$499.
Oh, $499. You could be on this helicopter going to the amethyst mine, all right? A friend of mine took those pictures. I mean, I've been there, but I walked way back in the old days. So there's lots of amethyst there. The thing that's really interesting is it has sort of a red tint, and that makes it a little more valuable, a little more unique, I think. And so, good cut Four Peaks amethyst brings a pretty high price. Well, and it has to because they're helicoptering people in and out, and the rock they're helicoptering in and out. And since I've been here, 40-some years, I can't tell you how many different people have owned, the Four Peaks mine, and most of them, of course, it was never profitable. It just didn't pay. But anyway, it's really nice stuff. And we have lots of other amethyst localities, but none of them have that Four Peaks, quality, that red color, the really nice gemstone. And some of them are okay. Petrified wood, wood that's replaced by quartz, thousands of tons since way back in the 1800s, collected around Holbrook. You can read some of the old literature. In 1906, they made it a national monument to try to protect the wood. But there's still lots of places outside the park where you can go today yourself and dig if you'd like to. So this is in the park. Most of you are familiar. The thing is that the trees were knocked down and buried quickly, so they didn't rot, they didn't decay. There was a lot of volcanic ash that was blown in that was silica rich, so the groundwater would dissolve the silica. When the groundwater started moving through the wood or came in contact with the wood, it started to replace it. So the silica lake water replaced the carbon wood product material and with quartz, and so the quartz replaced the wood. And you can get tables and anything you want made out of petrified wood if you have enough money. This is from one of the shops in Tucson. But incredible stuff. And that is our state fossil. I'm not even going to try to say that. That species of tree is the state. So we have state mineral Wulfenite, we have a state gem, turquoise, we have a state fossil, petrified wood. We do have a state dinosaur, Sonorosaurus. You can go to the Desert Museum and see it. We have a state metal, copper, and we have state drink metal. So we're set. There's also a stamp with Arizona petrified wood on. Agates, there's just lots of agates, and the point is that none of them have really been big production kind of places. Pat McMahon has this book he's published, you can look it up online. And it's a big, thick book of agates of the world, but he has 40 pages of pictures of Arizona agates. And these are just a few of the pages. I mean, incredible agates. I didn't, until he came out with that book, I had no idea. And I've been here all these years, that there were that many different really wonderful agates in the state of Arizona. They're just incredible stuff. And he has, at least a name of a locality for all these different places. So it's here, and I think that just none of the places have produced tons of agate. I mean, you really have to go out there and search and dig. But the point is, they're here, and people are finding them. They're really good. Fire agate, there's several places down by Safford that BLM has it. You can go dig. Ed's Camp, you used to have to pay to go there. I don't know if they're still doing it or not. Really unique kind of special stuff. Opal, I just put opal in because it's more towards a precious gemstone. So in Lapidary Journal, there's the Southern Skies opal from Ruby. This is what it looks like. That's a picture from the article. So you can see it has the play of colors, and that's the rough people. There's several claims there that people have for opal. And then this one, Morgan City Wash is just by Lake Pleasant. Not too far from here. This was Arthur Flagg's collection. This is opal that was in that collection. And to me, it's not very big. It's only an inch. So, but to me, it's unbelievable. But Morgan City Wash, I could spend a lot of years walking up and down looking. I wish I had a little more specific information about it. Doug Duffy, you know where it is?
Well, I have an idea, but not for sure.
Okay. I'd love to go find some of this opal. That'd be incredible. I mean, you know, that's Australian opal color. I mean, it's very.
We'll have to get a field trip together.
Yeah, we should. I think so. Finally, I thought I'd just say a little bit about silver and gold, just because that's something, of course, we're mostly interested in. Silver's been mined here for a long time. Silver King Mine near Superior, just quite a thing. It was claimed in 1875, and you know, in the next 14 years, they got about 6 million ounces of silver out of there. Just incredible quantity. After that, they got much less, and people have been trying ever since, but not really doing very well. But just amazing. Unfortunately, some of the specimens have been saved. They're quite valuable, but they're really attractive specimens. So these are 3 different native silver specimens from the Silver King mine by Superior. And you will see them occasionally, but and there are other silver localities, but it's probably the premier one. Then we have gold, thousands of ounces of gold recovered in Arizona. A lot of the big copper mines, it's a secondary byproduct. Most of that gold, you can't ever see it. It's fine grain, but in the smelting process or the recovery process, they get the gold out. There are 2 kinds of copper deposits on that list, ones that have gold and ones that don't, and there's something about the depth and the temperature that they formed at, whether they have the gold or not. And so we have lots of localities where people gold nuggets and panning for gold. These fairly recent, really unusual crystals from quartzite. They're not very big, but they're coming out of a dry placer up high above the creek that they've been working out there. But a lot of gold around the quartzite area. And then one in Yavapai County, and then the Mystic Mine in Maricopa County. So I see these specimens from the Mystic Mine, so I did a little research, and it's not very far, a few miles north of Surprise, okay? And some guys from Sun City did some prospecting, and they found the gold, and eventually in 1991 they put down a shaft there, and they only lasted about a year, but they got about 100 specimens or so of nice native gold that were put on the mineral market. And I saw one for sale just recently, not too long ago, from the Mystic Mine. But before you run out there, I did read that today it's under one of the holes of a golf course out there. But you can Google it and find out exactly where the golf course is. But to me, it says that they did this in 1991 and 92. And out in these big hills, there's still gold, and there's still opal, and there's still agate, there's still silver. And if I was 40 years younger, I wouldn't be standing here, I'd be out there looking. And I think that's